Hello everyone and welcome to another Add Maths tutorial video. Now I'll be discussing SPM 2016 Paper 1 question number 10 from Form 5 Chapter 4 Vectors short question. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. Diagram 10 shows a regular hexagon with center O. So this is the hexagon. In the question part A, they ask us to express vector AC plus vector CE plus vector CB as a single vector. Continue to read the question part B. Given vector OA is equals to A, vector OB equals to B, and the length of each side of the hexagon is 3 units. Find the unit vector in the direction of vector AB in terms of A and B. So this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solutions. So without further delay, let us start to solve the question now. For this question part A, I'm going to use the hexagon diagram as the reference together with my working here. Okay, let me show you the hexagon diagram now. So this is the hexagon diagram, okay, which I screenshot directly from the question 10. Okay, let me proceed the working over the side where the question asks us to express vector AC plus with vector CE plus with vector CB as a single vector. Okay, so the first step what we're going to do is we're going to add these two vectors, which is the vector AC and then the vector CE first. Okay, vector CB we will add it later on, but for now we will add these two first. Okay, so this vector AC in the hexagon diagram is this one, and vector CE is over this one. Okay, if you don't get it, okay, let me draw it for you. So this is the vector AC and this is your vector CE, and of course I have to label it. Okay, this is vector AC and this is your vector CE. Okay, these two vectors you can combine them into one single vector, which is vector AE. Okay, so how are you going to do that? So this is your vector AE, which is your resultant vector. Okay, this concept is through the addition of two vectors. Okay, vector AC plus with vector CE. Okay, so when you plus these two, so you will get vector AE. Okay, and then you plus with vector CB. So I hope you understand the concept so far. So this is your vector AE. Okay, let me draw the vector CB in the hexagon diagram now. Let me choose blue pen. Okay, so this is your vector CB. Okay, and we follow the direction given by the question. So this is the vector CB. Okay, in the diagram, so this is the vector AE and this is the vector CB. So how are we going to add them together? So we cannot just add them straight away. So we need to have a connection between two vectors. So how are we going to combine them? So since this is a regular hexagon, this vector CB, so we can find equal parallel vector. In this case, we can use the vector EF. So since vector CB is parallel to vector EF, so we can set our vector CB as vector EF. So let me draw the vector CB over here. Okay, since vector CB is parallel to vector EF, so this is the parallel symbol. So from here, vector AE you plus with vector EF. Okay, now these two vectors has the connection. So how do you know? You can see through the letter E over here. The first vector, last letter, and then the second vector, the first letter, they are the same. So from here, these two vectors, you can combine them into one single vector, which is vector AF. So this is your answer for the question part A. Okay, let me underline the solution, and then later on I'm going to draw the vector in the hexagon diagram here. Okay, that is all for the step-by-step working and solution for the question part A. Let us proceed to the question part B now. Let us write down the information given for the question part B over here. So given that vector OA equals to component A, vector OB equals to component B. So the question asks us to find the unit vector in the direction of vector AB in terms of component A and component B. So the first step what we're going to do is we're going to find the vector AB. So that will be our first step. Okay. So how are we going to find the vector AB? We're going to use these two vectors as the reference. Okay. So from here, vector AB. So this is your vector AB. So how to come up with the vector AB according to these two information? So you can come up a vector AB by using vector AO plus with vector OB. Okay. So from here, vector AO plus with vector OB, you will get back vector AB. And you see here, the letter O connects the vector AO and vector OB. So we have already using this information to find the vector AB. But then there is a catch. The question gives us vector OA, but then we are forming a vector AO. So what does this mean? So this means that it is in the opposite direction. So we need to come up with according to the vector OA. So how are we going to do that? So let me show you the working now. Okay, vector AO can also be equals to negative vector OA plus with vector OB. Okay, you can also write your vector in this way as well, where your vector AB will be equals to vector OB minus with vector OA. By the way, I'm showing this extra step in case if you don't know how to convert this vector AO to OA. Okay, so I hope you understand the working that I've shown to you. So in the question, vector OB is given that component B, vector OA is given as component A. So from here, you know that your vector AB is equals to component B minus with component A. So this is your first step. Okay, so I hope you understand the working that I've shown to you up until now. So the next step what we're going to do is we need to find the unit vector of vector AB. So this is the symbol of unit vector AB. So it is given that unit vector of AB, we can use this formula where vector AB you divide with the magnitude of vector AB. Okay, so vector AB we have already found in the question is B minus A. Okay, component B minus component A, and then you divide with magnitude of vector AB. So what is the magnitude of vector AB? So read the question carefully, where they mention that the length of each side of the hexagon is 3 units. Okay, in the diagram you know that AB is the length of the side of the hexagon. In this case, the magnitude of AB we can denote that is 3 units. Okay, so from here B minus A, where component B minus component A you divide with 3 units. So from here you should get your final answer of unit vector AB is equals to 1 over 3, okay, in a bracket component B minus component A. So this will be your final answer. Okay, let me underline the solution for the question part B. Okay, so that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future. And not to forget to share this video. Thank you everyone for your support, and I'll see you in the next video.